Okay, so hello and welcome back. We're looking at a case 3 example now of a geometric sequence, right? So I'm just going to put that out there, case 3 example. And remember, it's geometric sequence, right? Geometric. Now remember, I write down so that you can make notes, right, of a geometric sequence. Now, no different than our arithmetic sequence in the manner in which we have defined the cases. Case 3 was where the sequence is given, but with a constant unknown. Given sequence with a constant unknown, right? So that means there's a variable in there, but the variable only takes on one value or a specific value throughout the sequence, and then it would give you the type of sequence, right? So it's a given sequence with a constant unknown. The type of sequence is given. And the questions that you can be asked is to determine the sequence or determine value of the unknown, or you are told to determine the sequence, right? In either case, you have to calculate the value of the unknown first. And then finally, the manner in which we solve these questions, it is solved using the defining property, right? Solved using the defining property. Now remember, the defining property for a geometric sequence is that R, which is the common ratio, is equal to T3 divided by T2, which is equal to T2 divided by T1. Okay. So let's see what we can do here. Here's our first example. I'm going to use x plus 1, and that's a term in itself, x plus 3, and that's a term in itself, and then 2x plus 3. Okay, so let's see. As you know, this is given, and you're also told that this is a geometric sequence. So I would say the question reads, given the following geometric sequence, x plus 1, x plus 3, 2x plus 3, determine the value of x. So you're also told it is geometric. Now the moment you see these two keywords, geometric, and you see a constant unknown where the sequence is given, where you have three terms that are consecutive, 1, 2, 3, there are three terms, these terms come after one another, then you know immediately you can use the defining property. And the defining property over here, as you can see that this item over here corresponds to T3, that's T2, and this over here is T1. The defining property for a geometric sequence is that it has a constant ratio, which is made up of T3 divided by T2, which is equivalent to T2 divided by T1. Now this is already true, and the reason this is true is because they actually told you it is geometric, so this must be true. Now we can substitute in the values that we see there. Let's start with 2x plus 3 in the place of T3. So I put there 2x plus 3 divided by T2, which is x plus 3 in this case, is equal to T2, which is just x plus 3, divided by T1, which is just x plus 1. Now once you apply the LCD over here, or in some cases, as your teachers may call it, cross multiply, something I'm not a big fan of, it's really just applying the LCD, which is x plus 1 times x plus 3. It cancels on this side, you're left with x plus 1, and then that multiplies with that. So it gives us x plus 1 multiplied by 2x plus 3 is equal to x plus 3 multiplied by x plus 3 once again. So let's multiply that out. That's going to give me 2x squared. That's going to give me positive 3. That's 2x plus 3x gives me 5x. And on this side I'm left with x squared. And this is just the square of x plus 3, so it's going to be x squared plus 9 plus 6x. Okay, we can now simplify that. When I look at that carefully, I can see yes, 2x squared is 1x squared, so this cancels with 1 of that, and I'm left with 1 of it here. This cancels with 1 of that there. Right, and I'm just left with an x squared. 5x and 6x, I'm left with a 6x on this side, 1x. When I subtract from both sides, I'm going to be left with x squared on this side. Oops. Ooh. X squared. 5x and 5 of those x's cancel out. I'm left with an x here. Bring it over. I've got negative x. And 3 and 3, I'm left with a positive 6. Bring that 6 over. It becomes negative 6 equals 0. So now we've got to solve for x in this equation, right? So I've got x squared minus x minus 6 is equal to 0. I look for the factors of 6 that when I subtract them I get 1. And that's an easy equation. In this case it's just 3 and 2, because 3 times 2 will give me 6 and 3 minus 2 will give me the 1 that I'm looking for there. Negative 3, positive 2, x and x. Right. Now, the premise of this whole thing, from here onwards, is just algebra. It's about understanding that I've got to start with T3 divided by T2 is equal to T2 divided by T1. That's the important thing. The rest is just algebra. Just substitute and you figure it out. When I solve this over here, I can say, therefore, x is equal to negative 2 or x is equal to positive 3. Okay? Now, when you solve these questions, it doesn't mean you'll always get two answers. Sometimes you may only get one. It just so happened in this case we're going to get 2 answers. Both of these answers are valid to make this thing a geometric sequence. You don't need to get 2 answers. In some cases you do, like now. So now you can take that and you can back substitute in minus 2 and 3 into the x's, and then you can check whether you get a geometric sequence. So that's what I'm going to do next, because we've solved for the unknown. And now we take our sequence, which was x plus 1. Let me just make that blue again. X plus 3 and 2x plus 3. When I substitute in the values, as you can see over here, negative 2, that's going to be negative 2 plus 1. That term is going to be negative 2 plus 3. And this term over here is going to be 2 times negative 2 plus 3. And we can solve that. Okay, I'm just showing you the full substitution here. That's going to give me negative 1. That's going to give me positive 1. That's going to give me negative 4 plus 3 is negative 1. So that's the first one. I'm going to do the next one below. Right? I'll take the other one and I'm going to substitute in again there immediately. I'm going to say when I substitute in 3, I'm going to substitute in 3 in the x. That's going to give me 3 plus 1, which gives me 4. 3 plus 3, which gives me 6. And then 2 times 3 plus 3. What does this give me? That gives me 4. That gives me 6. And that gives me 2 times 3 is 6. 6 plus 3 is 9. Now this is clearly a geometric sequence, right? This is the sequence over here. And this is the sequence over here. Both of these are valid geometric sequences, because both values of x actually holds true. The property T2 divided by T1 is equivalent to T3 divided by T2. So valid geometric sequence. So as you can see, in some questions you may actually get 2 answers, and in other questions you may only get 1. In this case, once again, a valid geometric sequence. Okay, now if you want to know what's the ratio, you simply take 9 divided by 6. 9 over 6 is 3 over 2. Like 9 divided by 6 is equal to 3 over 2. And you can take 6 divided by 4, which is also equal to 3, because 2 goes in there thrice, and 2 goes in there twice. 3 goes in here thrice, and 3 goes in there twice. So clearly, from there to there you multiply by 3 over 2, which is 1.5. And from there to there you multiply by 3 over 2. So it's clearly geometric. From here to here, you simply multiply by negative 1, because negative 1 times by negative 1 gives me positive 1. Positive 1 times by negative 1 gives me negative 1. And so that's also a geometric sequence, because I'm multiplying by the same thing each time. And this sequence will just repeat itself. We'll go negative 1, 1, negative 1, 1, negative 1, 1, etc. The next term here will be 13.5, and so on. Okay, So that's a case 3 example. The important thing to note with case 3 is they tell you the type of sequence and they give you the terms, and inside those terms, those consecutive terms, given sequence, there's a constant unknown. When that constant unknown is there, all you need to do is use the defining property. In the case of a geometric sequence, it is the third term divided by the second term is equal to the second term divided by the first term. And you could have made this 10 and 9 and then 9 and 8, or any two consecutive terms with another set of consecutive terms of the geometric sequence, and it will work. Okay, good luck.